Okay everyone, here is another update about a new pixel art editor that I'm creating. Nodot is what it's called. And in the previous video, I think we went over some of the slider stuff. Color slider, color picker. So I did a little bit more work on it. We have this window here with a checkered pattern to indicate that it's transparency in this area. And we have this little indicator, brush indicator, following the mouse around. And we've implemented a brush size slider, and it updates the indicator as well. And I've also added a zoom, some zoom options here, so it zooms in. Now I guess I'll go over some of the code and talk about how it's been implemented. As you can see here, we have just a basic select element, and when you change the value, it runs this function, the zoom function. And we have a bunch of options with different values here, and the text that it displays, and by default 100% zoom is selected. So if we look at the zoom function, I believe I put it in the main.js file. I might move this to another file. I'm not sure yet. I just put it here for now. But it passes the element, the DOM element, as E, variable E. And then we set a variable, master.zoom, which is defined right here in the master object. The default value is 1. But we set it to whatever the value is in the select box. And then we set the zoom style on the canvas frame div element to the zoom. So what that does is it zooms this div that's in here. I'll show you where it is. Right here, ID equals canvas frame. So it zooms this. You can see the zoom currently is set to 5. And inside it we have a canvas div with a bunch of canvases which correspond to the different layers that we'll be drawing to. So yeah. So it changes the zoom property of the style of that div whenever you change this. So if we set it to 800, zoom gets set to 8. Now the brush indicator here, after we change the size of the brush, it creates this brush image here, and then we trace the edge of it to get all the different points, and then we draw those points to another canvas, and the canvas follows the mouse around. That way we don't have to keep drawing to a canvas when we move the mouse. We just draw it once, and then we could position it by the mouse. So it saves on the number of drawing operations by just drawing the indicator once. And we'll have to implement a way so that it snaps to each pixel. Right now it's just, it doesn't align to the exact pixels when we're zoomed in. So I'll implement that in the future. I guess I could show you the code for the indicator brush thing. Okay, so when we update the brush size, it basically, this is the function right here. It goes through and gets the brush canvas here, and then it creates some drawing operations and draws within a certain radius from the center of the canvas using the current color as the fill style. And then we trace the edge of the brush. We get the width and height of the brush canvas because it changes size when we change the size, obviously. And then we get the image data of the brush canvas. We have a brush edge array to store the points as we trace along the edge. First we find the starting point, so we kind of cycle through all the pixels from the top left until we reach a pixel that isn't transparent, which means that we found the edge of the brush. And then we set these values to the end so that the loop stops and we can continue. And if it checks first to see if anything's found, and then starts pushing the points into the brush array. We have a step array, and then we do this while this is true. So we find all the points until we get back to the beginning point. So keep doing this until we reach the beginning point. So first thing is we step 1 pixel along the edge, which we pass in the position of the pixel data, and then this function checks each pixel around the point. So we pass in four pixel positions or data or whatever. I guess we check the fourth value of the pixel color because it's RGB and then A for alpha. So we check the alpha color because we want to check if it's either transparent or opaque. So right here, A, B, C, D, this shows the organization of the pixels. We get like a 2 by 2 pixel area. And so if the top left pixel equals 0, 0, 0, then it moves. Let me say that again. If the top left pixel is 0, top right is 0, bottom left is 0, and bottom right is 0, then it adds 1 to the X position, so it moves right 1 pixel. If top left is 0, top right is greater than 0, meaning that there's some opaqueness to it, and bottom left and bottom right is 0, then it adds 1 to X, so it moves right 1 pixel. And basically all of these it checks to find which direction. Here it adds 1 to the Y position. Here it subtracts 1 from the Y position. Yeah. And then it returns which way to go, basically. So then it adds that, adds the direction, steps in the direction basically, and then it pushes that position into the brush edge array, and then it keeps doing that until it gets to the beginning. After that, we have all the points, and then we run this function, draw brush edge, which is down here. So we clear the indicator canvas, and then we resize it. We might not have to clear it, since I think resizing it automatically clears it. But anyways, we set the size to whatever the brush canvas is times the zoom, and then we go through and create a path using the points, and we basically draw it to the indicator canvas using the context indicator, whatever. Line width 0, stroke style, and then we create the stroke. And the reason we do it this way with the zoom is because if we didn't do the zoom, then it would just be all chunky, right? So there's that. And the positioning of the indicator is done in the on mouse move function. Canvas indicator, we just set the left property of the style of the canvas indicator. We get the mouse position, the top left position of the overlay div using the get bounding client rectangle function, and then minus the border and minus half the width of the canvas indicator, just so that it's centered on the mouse. And then we add px for pixel. And we'll have to add a little bit of code in here to snap it to the pixel grid when it's zoomed. So I'll probably do that next. Down here we have this section of code commented out. And this basically is the actual pixel location on the canvas itself that we'll be drawing to. So the position times the zoom divided by the zoom, etc. That basically gets the actual pixel location on this canvas right here. So right here would be 0, 0. And as you move down to here, it'd be 0, x, 8, y. This would be 16, y, 24, y. This would be 24, 24 over here. But anyways, I think that explains what I wanted to explain. So you could get the code, the source code, on GitHub. Here's the URL of that. And it's open source, so you could check it out and do whatever, contribute. So I think that covers it for now.